Good morning, students. We will discuss the first chapter of class 12, that is electrostatics. What is electrostatics? It means electro. It deals with the electric charges, and statics means at rest. So, in the whole chapter, we will discuss the properties which will be created by the charges at rest. Now, charges at rest can produce electrostatic force, electric field, electric potential. So we will discuss these properties later on. First of all, हमें यह समझना जरूरी है कि what are electric charges, चार्ज कहाँ से कैसे डिफाइन करें. तो ये बहुत आसान है क्योंकि ये हम बहुत जूनियर क्लासेस से पढ़ रहे हैं कि एवरीथिंग इन दिस वर्ल्ड, every matter is made of atom and molecules, and these atoms, they are also made of proton, electron and neutron, which are known as fundamental particle of the matter. So electric charges, we know already that this is the property of fundamental particles of the matter, such as proton and electron, and due to this, these charges on the fundamental particles of the matter, they give rise to the electrostatic force between various charged bodies. Atom as a whole is electrically neutral, but the constituent particle of the atom, they are having charge. Proton and electron are the example of that. Now, the very important property of charge is charge cannot exist without mass. That is, if a body or any particle having charge, it must be having mass also. But the reverse is not true. That is, mass can exist without charge. For an example, neutron. Neutron is chargeless, but it has a mass. Now, types of charges. Types of charges, we can have two types of charges which are possible. One is positive and another is negative. Two types of charges are possible. If we talk about the properties of charge, simple properties of the charges, then first of all you must know that SI unit of charge is coulomb. This is the SI unit of the charge. How we denote charge in SI unit? It is denoted by the coulomb. Now the next one is very simple. If you have the like charges, then these will repel each other. And if we have unlike charges, then these will attract each other. But the most important, how we will be confirming that two bodies both are being charged. दोनों ही बॉडी चार्ज है, इसका कंफर्मेशन किस प्रॉपर्टी से, रिपल्शन या फिर अट्रैक्शन, किससे श्योरिटी आएगी? तो श्योरिटी रिपल्शन से आएगी. रिपल्शन इज द श्योर टेस्ट ऑफ charging of both bodies. We will be sure that two bodies will be charged only when they repel each other. Why? Because attraction is possible between a charged and uncharged body. So, for example, if you rub a balloon over your head and try to make it stick on the wall, you will find it will stick. That is, by rubbing, balloon become charged, but wall is uncharged. So attraction is possible between a charged and uncharged body, but repulsion can be between two similarly lightly charged bodies. So we will be 100% sure that two bodies are charged only when they repel each other. So these are the properties, simple properties of the charges. Next is, there is a basic, now the basic properties of charge, very important, basic properties of the charge. First is, charge is additive in nature. What does it mean? As we all know, charge is scalar. That's why it can be added like numbers. So charge is additive in nature. For example, if we say Q1 plus Q2 is 0, what does it signify? It signifies that Q1 is minus Q2. Both the charges are equal and opposite, only then they will be added to give 0. So this indicates the additive nature of charges. That is, charge is additive in nature as it is scalar quantity. The second property being quantization of the charges. Quantization of the charges. Now quanta means small packet. So quantization of the charge is very important property. First of all, you must know the basic or fundamental charge. It is the smallest possible charge. What is fundamental or basic? Fundamental or basic, which cannot be further divided. So the smallest possible charge is denoted by E, and its numerical value is 1.6 10 raised to the power minus 19 coulomb. It will be negative for electron and positive for proton. So this is the fundamental. Fundamental means the smallest possible charge which cannot be further subdivided. We cannot divide it. So that's why it is called fundamental or basic charge. So charge on any body, a body which is charged, will have the charge, all free charges are found integral multiple of basic charge. This is very important. That is, charge on any body is found to be multiple of basic charge E. Now it can be positive or negative. What is N here? n is the integer, and or you can say the number of electron lost or gained by body. So quantization, quantization signifies that charge is always integral multiple of the smallest possible basic charge, that is E, whose numerical value is 1.6 into 10 to the power minus 19 coulomb, or more precisely you can say 1.602 10 raised to the power minus 19 coulomb. Now this will have negative or positive nature. Negative is on electron minus E, and for proton it is plus E. The numerical value remains same. And the quantization indicate that all charges available, they will be the integral multiple of that basic charge E. It can be positive or it can be negative. N is the integer, any number, full number, and or you can say number of electron lost or gained by the body. So quantization means the body cannot have. Can a body have charge E by 2? Answer is no. Can a body have charge 3E by 4, negative 3E by 4? No. The charge can be plus minus E plus minus 2E plus minus 3E, like that. No values in between E and 2E of charges is not is possible. That is in fraction of E. So that is quantization. Now important question of the NCERT. This quantization is valid only for microscopic bodies. Quantization is possible. Quantization is possible only for what? Only for the bodies which has n, that is integer or number of electron lost or gained by the bodies, very small in numbers. For example, n, if it becomes 10 raised to the power 1000, now it becomes very large, very large. Then the charge will not appear as the multiple of E, but it will become continuous. It appears to be continuous. That is, quantization is not done. So quantization is done for the microscopic bodies for which n is finite, small values, and for macroscopic bodies for which n becomes very large, charge appear continuous. That is quantization is not possible. So quanta means small packets. When you have the charge as a multiple of E, then it can be quantized. You can count them. But if it appears and becomes very large, you cannot count them, then it appears continuous. Continuous, then continuity means charge will be not quantized. For macroscopic bodies, the charge n will be very, very large. That's why you cannot have quantized property of the charge. Then charge will appear as continuous in nature. And the last property is the conservation of charge. Conservation of charge, that is very simple words. In simple word you can state that charge cannot be created or destroyed, but can be transferred from one body to another. So this is very simple, that charge cannot be created or cannot be destroyed, but it can be transferred from one body to another. But now you are smart enough to understand it in another way, that charges can be created or destroyed, but in a pair of equal and opposite charges. You can create or you can destroy the charge, but always in pairs. For example, you can understand by example pair production. Pair production means a gamma photon. What is gamma? Gamma is the energy. Where energy is absorbed by certain matter, then what is created inside it? An electron and its antiparticle, positron, will be created. Now you can see yourself what is gamma. Gamma is the energy. Gamma photon, that is energy. When it falls on any matter or any substance, what is created in it? Electron and positrons are generated. So you can see yourself energy will not have any charge. So will have here on right hand side, you will find negative and positive. Both are equal and opposite charges, so their additive sum is 0. So that indicate that charge is conserved. Another example is also there, and this is called pair annihilation. Pair annihilation. Pair annihilation means if electron and positron they get combined, then they will create energy. What is now you can ask that why electron and positron is created by one only single photon, that is single quanta of the energy. But when both combine each other, then why two gamma photons are created? So the answer is very simple. We required when electron and positron combine, we get so much of energy that we can have two quanta of energy. Two gamma photons are created. Again, you can say the charges on left hand side is 0, so as the charge on the right hand side. So these are few examples of conservation of the charges. So these three were the basic properties of the charges, which are very important. Now after that, you can you are in a position to understand the how the charges are developed. First of all, method of charging of bodies. First way is charging by friction. Charging by friction. Now, what does it indicate? Charging by friction. As we all know that every matter is made of atoms or molecules, and if we see that body A and body B is there, then you will find that it will be made of atoms, and in atoms we have positively charged nucleus and electron revolving around it. Same is the for body B, and you know number of protons are same as number of electrons. That's why atom is electrically neutral. Same is in the case of body B. Body A made of atoms or molecules, and atoms, you know, inside nucleus we have positively charged protons, and around nucleus electrons are revolving such that both number number of proton inside nucleus and number of electron outside nucleus revolving around it, both are same in numbers. That's why atom is electrically neutral. But you know that these electrons when revolve, they revolve in various orbitals. They are revolving in various orbitals. Now those electrons which are very close to nucleus, they will be strongly attracted by the positive charge of the nucleus, and those which are far away from the nucleus, they will be least attracted. So what will happen when we try to rub? Initially the charge on both the bodies is zero, because the number of proton inside nucleus and number of electron outside the nucleus, both are same, as both the bodies A and B, they are made of atoms, and atoms are as a whole is electrically neutral. But what happens after rubbing? If we rub these two bodies against each other, then what can happen? Loosely bound electrons are transferred from body of lower work function to body at higher work function. Now, how to understand this charging by friction? When you rub two bodies against each other, then you know body is made of atoms, and in atom we have two types of electron. One which are very close to the nucleus, they are tightly bound, and those electrons which are far away from the nucleus, in valence shell you can say, they are loosely bound. So when we rub two bodies against each other, then what can happen? The loosely bound electrons may get transferred from the body of lower work function. Now, what is work function? You must be knowing it. That work function is the amount of energy required to remove electron out of the atom. That is called work function. So, the body which is at lower work function, you can remove the electron from body, that body, and they will be getting transferred to the another body which is at higher work function, from which the electrons are very difficult to remove. So let us suppose that body A is at lower work function, so it can easily lose electron, and this is body B which is at higher work function, it will gain electron which is released by the body A. So for example, let one electron is removed from body A and it get transferred to the body B. Now you all know earlier, before rubbing the two bodies, what was the scene? Number of proton and number of electrons both are equal in both the bodies. Then what will happen now after rubbing? Electron get transferred from the body A to body B. So it is losing electron. So you all know now electron is negatively charged. So it will lose electron. That means it becomes, after rubbing, it becomes positively charged. And the body is gaining electron, negative electron. That's why it is become negatively charged. So that is called charging by friction. When we rub two bodies against each other, the loosely bound electron may get transferred from the body of lower work function to the body at higher work function. Hence, both the bodies becomes equal and oppositely charged. Got it? Now, the simple fundamental rule we have already learned that charge cannot be created, charge cannot be destroyed. Only there is a transfer of charge is taking place. So important point is that the body which loses electron will acquire positive charge, and body which gains electron will acquire same amount of negative charge. Now both the bodies become equal and oppositely charged. One thing you have to note down, that the body which loses electrons, since the electron having certain mass, so they become, after losing electron, they become lighter in mass, and the body which gains electron, they are gaining electrons, so that's why it will be slightly heavier in mass after rubbing the two bodies against each other. So that's how the two bodies become charged after rubbing each other. Many examples are there. For example, if you go glass rod rubbed against silk cloth, then you will find after rubbing the glass will acquire positive charge and silk will acquire same amount of negative charge. Now you can understand it yourself that why it becomes positive and why it becomes negative. Now you know very well. Since glass is having the lower work function, that's why it loses electron, and it will be at higher work function. That's why it is gaining the electron. The same happens ammonite rod when rubbed against fur. Fur, what is fur? It is a woolen, soft wool, and the teddy bear made of that fur only. So fur becomes positive and ammonite rod becomes negative. Many more examples in daily routine life. When you enter in room after traveling certain distance on bike or scooty, and suddenly you enter in the room and touch the metal knob of the door, and sometimes you find that very mild shock being felt by you. Why it happens? ऐसा क्यों हुआ कि आप बाहर से ट्रेवल करके आए और आपने जैसे ही रूम में एंटर किया और नॉक को मेटल नॉक को टच किया डोर पर, आपको एक हल्का सा कभी कभी एहसास होता है, शॉक लगता है। तो ये वही फ्रिक्शन, हमारी बॉडी जब बाहर से आ रहे हैं तो एयर बहुत तेज, अगर आप चल के आ रहे हैं स्कूटी बाइक पर, तो वो जो एयर है वो आपकी बॉडी से रब होकर आपकी बॉडी में चार्ज डेवलप कर देगी। और ये जो चार्ज होता है, ये जो चार्ज की बात कर रहे हैं हम, जो डेवलप हो रहा है फ्रिक्शन से, इसे बोलते हैं स्टैटिक चार्ज। स्टैटिक चार्ज, इट इज नॉट कंटिन्यूअसली फ्लो, ये फ्लो नहीं हो रहा, ये स्टैटिकली डेवलप हो गया, ये फ्लो नहीं हो रहा, करंट नहीं बना रहा। ये करंट आपको शॉक कब लगा, जब आपने मेटल को टच किया तो आपकी बॉडी से कंडक्ट हुआ। तो स्टैटिक चार्ज बीइंग डेवलप्ड बाय द फ्रिक्शन on any insulating body when both are rubbed against each other, the static charge being developed on the body. This is very important to note down, static charge being developed. Another example, thundering. Clouds में आपने देखा होगा थंडरिंग, लाइटनिंग, थंडरिंग और लाइटनिंग। तो वो जो लाइटनिंग कॉज होती है वो भी इसका एग्जांपल है, चार्जिंग बाय द फ्रिक्शन। व्हेन अपोजिटली चार्ज क्लाउड्स they touch each other, then again you will find the lightning. So many more examples you can experience in daily life based on the charging by friction. But the cause of charging by friction is very simple. It is charging by friction means when two bodies are rubbed against each other, they both become equal and oppositely charged, and the charge developed is static charge. The next one is very important and very interesting, and this is called charging by induction. This is very important. Charging by induction. If you have a conductor, this is a conductor, and this is insulating stand. Mind, this is insulating stand. It is not directly touching the earth, and this is the conductor. Now what happens? This is the glass rod. It is being brought near the uncharged conductor. Now this is conductor. Now see what is really happening. This is a glass rod which is rubbed against silk. Now you are aware that when glass rod is rubbed against silk, it will be positively charged. It will be positively charged. And when it is brought closer to, not in contact with the uncharged conductor, closer to the conductor, uncharged conductor, and inside conductor what we have? Inside conductor we have free electrons. So what will happen now, as this glass rod